अच्छा, so we're gonna start with the कहाँ पे थे? Where were we? This one, right? The idea, where were we working on at? अच्छा, ठीक है, we were somewhere over here. Yeah, this one. So I think I had explained to you the splitting pattern, right? So again, just a quick recap. Okay, what last class, ठीक है, what did we learn? Okay, we learned a couple of things. We learned that number one, there's going to be chemical environments, right? ठीक है, that was number one. As a second, we learned that they're going to be you'll get to know the number of protons in those chemical environments. ठीक है, so how many protons are present in those chemical environments? और फिर उसमें the last thing was number three. So that was the splitting pattern. It tells you the neighborhood environment. Like how many protons does the neighbor have? About the neighborhood protons. ठीक है. So there were three things that you were able to figure out using when you look at a mass, not a mass, a nuclear magnetic resonance, right? Uh, so it will tell you the number of protons. ठीक है, three, two in this, three in this. ठीक है, that's the relative heights will tell you. The relative heights will are going to tell you the number of protons. And the splitting pattern, the n plus one rule. If the neighbor has zero H's, it's a singlet. If the neighbor over here has three H's, it's a quadruplet. If this one has, the neighbor has, I mean, its neighbor has two H's, then that's a triplet. Okay, so we talked about the splitting pattern, and that's pretty much it. Okay, that is all that is required to figure out what the molecule is going to look like. Okay, so we'll start doing some questions on this. But is this clear up till this point? Zaina, Maheen, is this clear? Afan, clear?
Sir. Yes, sir.
Yes, sir.
Acha, and then the next thing is that the other thing is okay, just a few minor things. One thing that I told you about splitting pattern was that the OH and NH2 they don't cause splitting and are always singlets. Okay, that was one thing. But then there are a few more things which are probably written over here. Okay, those things are okay, I'm going to write them down again. Okay, they're not that important. Okay, the first thing is you don't talk about NMR resonant frequencies. Okay, you don't use the word resonant frequency. Instead, what you use is the term chemical shift. And the units for chemical shift are delta parts per million. So you don't use the word resonant frequency. Instead, you use the word chemical shift. Okay, what is the chemical shift? It simply is the relative peak of the it's the relative peak of the hydrogen protons compared to a standard reference. Not the relative peaks, it's the relative frequency of H protons compared to a standard reference, which is known as the TMS reference. So what that is that if you have a lot of hydrogen protons resonating like this, so what you're going to have is you're going to have a reference hydrogen proton peak over here. That's going to be known as that's at 0 delta parts per billion. Okay, that's your standard. So it's compared. All the hydrogen protons and their frequencies are basically compared to the standard reference. And what you do is you compare it. You try and figure out how shifted these peaks are compared to the standard reference hydrogen proton. Okay, so there's a
सर ये
particular
SPPM क्या है?
वो यूनिट है उसका डेल्टा पार्ट्स पर
Oh,
मिलियन.
सही.
अच्छा, so the idea is that you don't use the word frequency. What you do is you use the word chemical shift. You figure out that if these protons are resonating at this frequency, so how shifted are they compared to the, because all the frequencies are different, right? So there's a standard reference. So there's a hydrogen proton peak, which is used as a standard hydrogen reference. And you try and figure out how shifted these frequencies are compared to the standard reference. Okay, is this clear?
Yes, sir.
Like,
Yes, sir.
okay. Um, so the absolute frequency we're not interested. We're just interested in how shifted the frequency is compared to the reference. And what is the reference? This TMS is the reference. It's a particular type of hydrogen proton. So they compare the hydrogen proton frequencies with that one. And that's known as tetramethylsilane. It's kind of one of the most shielded hydrogen protons. So it's got a silicon and tetramethyls. So this is what it is, right? So that's tetramethyl silane, and all the frequencies are compared. All the hydrogen. This has a very strong reference peak. Why? Because all the 12 hydrogens have exactly the same environment. So it has a very strong hydrogen proton peak. So it's whenever you do an NMR, this one is clearly identifiable. So you know which one is the TMS peak. Uh, and then you compare all the other hydrogen proton environments with this one. TK, and you try and figure out how shifted they are. So that's one thing. अच्छा, और इसके ऊपर they're not going to ask you a lot. They're just going to ask you what is the purpose of TMS. So you're going to tell them that it's used as a reference for hydrogen protons. TK, it's used as a reference. The other thing is, okay, there's another thing which is kind of slightly more important, and that's the role of heavy water. That's heavy water is D2O. And what is D2O? D2O is deuterium. That's the other isotope of hydrogen. That's a very rare isotope. It's 2 and 1. This deuterium doesn't resonate. Why? Because the nucleons are all paired. So this one has 2 nucleons. So which means that they are paired, which means that it doesn't have a dipole. No dipole or spin. So it's not going to resonate. right? So the purpose of adding heavy water is that normally what happens is when you do NMR in heavy water, so whenever it's done in heavy water, what happens is that your OH peaks disappear. Your OH, whenever you have an OH hydroxy, whether it's a carboxylic acid OH or an alcohol OH or any OH whatsoever, this it kind of disappears because what happens is that the O over here, the H in OH is going to be displaced by D plus one ions. So you'll have a frequency, and this one is not going to have a frequency, a resonant frequency. So one of the peaks is going to disappear. TK, is this clear?
So it means like only one of the peak will disappear. Like only R peak will come, no OH peak.
Baki, all the rest of the peaks will still be there. There's not going to be any OH peak. For example, over here, if you if you try and do the NMR spectrum of any molecule that has alcohol, 1 second, can't get. We did do. I mean, for example, over here, this molecule is going to have three chemical environments, right? There'll be three resonant frequency. But if you add heavy water to it, then this hydrogen proton is not going to resonate because it's going to get displaced by D, TK, the other isotope of deuterium. Is that clear?
Yes, sir. So, sir, in NMR, so we need heavy water for its
No,
use.
not necessarily. But if you want to find out okay, which peak belongs to OH, so not
Oh,
only OH, NH2B, TK, amine peaks also disappear. Alcohol, amines, and carboxylic acids, they disappear. Same is the case with amines because they also tend to ionize. So amines have a tendency to ionize, and they also tend to lose their H plus one ions, which can get displaced by deuterium isotopes. Okay. So those peaks are going to disappear. So that's the purpose of adding heavy water. You clear?
yes, sir.
Achha, so the rest of the stuff is that so we'll just start doing questions now. And also remember that the chemical shift values for different uh for different chemical environments would be given in the data booklet. Okay, so it's somewhere over here. 1 second. We'll come to carbon 13 NMR later on. This is the proton environment. So the hydrogen proton in a carbon chain, whether it's just CH3, this is the environment. If it's an alkane type environment, if it's just a carbon chain, then it's 0.9 to 1.7. If it's if the alkyl chain, if the hydrogens are next to aromatic ring, which is benzene, so it's going to resonate over here. So all the different environments are given. If the hydrogen proton is on the benzene, then it's 6 to 9 TK. If it's part of the aldehyde, that's 9.3. If it's part of phenol, that's 4.5 to 7. So all of these environments are given. Some of them are easy to spot, but the others are very overlapping. Remember, carboxylic acid has a unique environment, this hydrogen proton. The amide also has a very unique environment. All the other ones are they're kind of overlapping with each other. So I'm going to do some questions now for NMR. So remember, NMR questions are like solving a puzzle. The first thing that's going to happen over here is that remember you have to the easiest way to figure out what the NMR is. Okay, let's try and analyze the NMR spectrum over here. How many chemical environments do you see over here? कितनी है? That's four chemical
Four.
environments. ठीक है, so you've got you've got four chemical environments. What else? Uh, the height is not given, so you don't know how many protons in each chemical environment. So that data is missing. I think there's going to be more protons over here, slightly fewer protons in this one, and very few protons in these two environments, right? But the splitting pattern is given. So I know the neighbor of each one. If it's a doublet, that means the neighbor is. I know the neighbor is what? The neighbor has how many H's? One H, right? Is that clear? It's going to have one H. This one is a doublet as well, so that means the neighbor has one H. So must be CH. This one is a singlet, so that means neighbor has no H, right? At least no H atoms. This one is a multiplet, so that means the neighbor has a lot of H's. So might be in the middle of the chain. Is that clear?
Yes, sir.
Yes, sir.
ठीक है, and that's the only information that you're getting. So that is not sufficient to figure out what the molecule is. I can't draw a molecule based on that. Okay, the neighbor has one H, this neighbor has one H. I just know that there are four environments. So the idea is that isomers are going to be very useful over here because you can eliminate a lot of isomers by just this data alone. So isomers are going to be very, very helpful over here. So based on the information that's given, he says that it's a saturated alcohol. That means it's an alcohol with no double bonds. He's given you the mass to charge value. This is the MR, the molecular ion peak, right, which is the heaviest peak. So the MR is given, and he's given you the MM+1 ratio. So that tells you the number of carbon atoms. ठीक है, remember mass spectroscopy. उसके अंदर you can figure out the number of carbon atoms if you use this formula 100 over 1.1 into M+1, which is 0.9, divided by your M peak, which is 20.4. ठीक है, is this clear? So can somebody solve this and tell me what you get for this?
Sir, 4.
It's 44.1.
अच्छा क्या 44 पॉइंट नहीं 44.1 नहीं होगा
तो मुझे 4 आ रहा है.
4 चलो ठीक है you got 4 carbon atoms अच्छा so it's an alcohol with 4 carbon atoms right अच्छा so it's an alcohol with 4 carbon atoms ये ना so it's an alcohol and it has 4 carbon atoms ठीक है and this is the alcohol does it have an MR the molecular N peak as 74 इसका करो C4 that's 12 into 4 that's 48 with one oxygen so if you add an oxygen so that's going to be 62 and I think there are 12 H's कितने H's and that's 8 नहीं how many H's do you have is this 74 or not
Yes, sir,
Four,
74 है.
74 है ठीक है so it is 74 right but we don't know whether it's this one right okay this is not the only alcohol that's going to meet the because there's going to be a lot of isomers right so you could have the OH group on the second carbon atom as well and the rest are all H atoms ठीक है, so the rest are all 8 atoms. अच्छा, similarly you could have um so the OH group could be on the second one, or you could have a branch structure as well. And the OH could be on the first carbon atom, right? And the rest are all. You remember the NMR is not going to be sufficient. Or maybe there's probably going to be one more, which is that it could be a branch structure with the OH in the middle.
So we have to draw all the structures, like फिर हमें पता चलेगा कि कौन सा
हाँ,
cell बना है.
क्योंकि just this information is not sufficient to figure out what the molecule is, right? We just figured out that it's an alcohol. It's got an MR of 74, and it has see, पता था, it has an MR of 74. That's it, and it's a saturated alcohol. That was the only information that was given, right? So I drew all the 4 carbon atom alcohols. I think that's it, okay? Uh, because I can't make any more branches. The OH could be on the first carbon atom, the OH could be on the second carbon atom. In the branch structure, that's the same. The OH could be on the first one or it could be in the middle, right? अब मुझे बताओ which one of these is going to give you this? ठीक है, now it's going to be easy. Okay,
The last one?
ये वाला?
Yes.
नहीं, this one has how
Yes,
many?
sir, this one I think.
नहीं, this one has how many environments? ये जो H's है, aren't all these H's exactly the same? But all these H's, don't they have the same environment? और वो वाला जो H है ना, the last one, that's slightly different. ये क्या वाला? ठीक है, this one is the only one that's slightly different. So how many environments? It's got two environments. तो ये तो नहीं है. This one has 4 environments. Is this clear?
Yes, sir.
अच्छा, तो फिर और ढूंढते हैं कि what else? अच्छा, we can go with how many environments over here? That this is one CH3. That's one environment. This CH3 is slightly different. That's the second environment. This CH2 is different. This H is different, and this OH is different. So how many environments is this? This is one, two, three, four, five. 5 है. So I've got only 4. ठीक है, clear?
Yes, sir.
अच्छा, इसमें how many different environments in this one? It's this CH3 is different. This CH2 is different. This CH2 is different from the other one. क्योंकि ये वाला जो CH2 है ना, this is bonded to a CH3. That CH2 is bonded to और वो closer to OH है. So that's different compared to the left one. ये वाला, this one is even different. ठीक है? Why? Because it's even closer to OH. So the chemical environment is different and the OH. So that's 5 peaks. Is that clear? This one.
Yes, sir.
Yes, sir.
इसकी कितनी peaks है this one? क्या are these two CH3s exactly the same or are they different?
They are the same.
ठीक है, because they're bonded to the same carbon atom. So these two CH3s are exactly the same. This H is different from all the others. The CH2s are different from all the others, and there's this OH. So how many environments? That's a total of 4 environments, right? So you got 4 environments, right? So this is the only one that's got 4 environments, and the splitting pattern will be exactly the same as well. Okay, इसका splitting pattern देखो कि like if I zoom in, these hydrogens have the neighborhood is 1H, right? So this is going to be a doublet, right? Is that clear? क्योंकि
Yes, sir.
neighboring carbon क्या है? That's 1H. Acha, the OH is never going to cause splitting or it's going to be split, so that's a singlet. Acha, this CH2 has one H. ठीक है, remember you're going to ignore the OH. The OH and NH2 they never split. ठीक है. अच्छा अब so this CH2 the neighborhood is 1H. So that's a doublet as well. अच्छा फिर finally रह गया कि you got this H. Now that H is in the middle. It's surrounded by H's. हर तरफ H's हैं उसके. Lots of H's. So that's a multiplet. ठीक है. This one is a multiplet. Is that clear? Which is exactly what we have over here. Two doublets, one multiplet, and one singlet. ठीक है. Clear है?
Yes, sir.
और उसको अगर further check करना है ना, like although we've reached our answer, this is the answer. If you want to further check this, you can open the data booklet, or the data booklet would be given to you, and you can kind of guess what the environment is from the data booklet. For example, ये OH, alcohol OH, right? I'm going to give values for each one of them. लेकिन ये overkill हो गया, ठीक है? Most of the time you don't need to open this. So the alcohol OH, that's what is the range? It's 0.526. ठीक है, that's the chemical shift value. So the alcohol OH is going to be, what is the range? It's 0.526, which is a very large range. Acha, then there's a CH2 which is next to an alcohol, right? So I'm going to look for that. So I'm looking for a CH2 it's this one. मतलब OH तो नहीं है, लेकिन the closest I get is CH2 next to an O. So that resonates around 3.224. Is that clear? So CH2 next to O, that's 3.224. सही है? तो किधर गया? तो ये जो doublet है ना, this is 3.224. ये भी clear है? Doublet, right? अच्छा अब आ जाओ इस पे. This CH which is part of the alkyl chain. It's उसके neighborhood में क्या है? That's just carbon chains, right? So that's probably the first one. The alkane type environment, right? That's 0.9 to 1.7. So in दोनों की actually ना, both of these are going to be 0.9 to 1.7. This CH, that's got an alkyne because there's no electronegative atom in its neighborhood or any alcohol or a double bond, anything. It's just an alkane type environment. This one also has an alkane type because the neighborhood is CH. उसके बाद क्या? That's again CH2. So its immediate neighborhood is alkane type. So that's also 0.92. What? 1.7. ठीक है, clear है? So I'm going to see if I get the same exact result. So remember the singlet OH, that's 0.526. So that's within that range. The doublet over here, the smaller doublet. Remember, there are two doublets. There's going to be a smaller doublet, CH2, or ये जो two methyl groups, that's going to be a big doublet. Both of these, this is 0.9 to 1.7, the big doublet. So that's within that range, 0 to 1 के बीच में. And the smaller doublet was 3.2 to 4. So that's exactly somewhere between 3.2 and 4. Clear path? और the
Yes,
multiplet,
sir.
ठीक है, multiplet कहाँ था? 0.9 to 1.7. So this tiny multiplet is 0.9, 1.7 के करीब है. It's somewhere around 1.7, 1.8. So I'm getting exactly the same thing. ठीक है? But the idea is that by looking at the splitting pattern and by looking at the number of environments, that should be sufficient. You don't need to open the data booklet. ठीक है? Okay, I just knew, बल्कि in this question, I just figured out that this one had four environments. All the other ones, this one had two environments, this one had five, this one had five. So based on just one thing, I was able to figure out that this structure belonged to this one. TK, is that clear?
Yes, sir.
So that should be sufficient. So we did deduce the structure of T. Baki, we describe and explain which proton type is responsible for each of the absorptions. Uh, why is 1.8 is a multiplier and 2.5 is a singlet? Say it and explain the spreading pattern. Describe and explain how the NMR spread. Yeah.
describe it like the second one, like how we described it, like हम कैसे लिखेंगे आंसर को?
I said the answer would be written in exactly the same way that what you can do is, the simple thing is, what you can do is you can exactly draw this like this and just write all of this. That's it. Like which proton, we push, right? The question is which proton, explain which type of proton is responsible for each of the absorptions. That's it. So you've already drawn this molecule. He drew the structure earlier, right? This one. And then he's asking for which one is responsible for which thing. Is that clear? So I think there's a lot of space.
Yes, sir. And
ठीक है? Or you can write it in point form that you can state that. But the other way of writing it is kind of confusing. Like, but I'll show you the marking scheme for this. I think the clearest possible way is you draw the whole molecule and write on top of it. That's it. That's the clearest possible way of writing this. Okay. But I'm just going to show you the marking scheme for this. It's 1441. One second.
so sir, ये marks तो नहीं करते ना? For example, हमने structures बनाए rather than answering like in point form.
नहीं. But it's not. But ये वो नहीं है ना. Economics नहीं है ना. Yeah, it's not Park studies. It's in sciences. As long as you clearly tell them that this is the answer. अच्छा और remember उसके अंदर it's always के point form is more. I mean that's why they always discourage that you're not supposed to write essays or don't write it in essay form. अच्छा W1441. One second. Where's the yeah. ये दिया हुआ ना. ठीक है. I mean that's the exact same structure and he wrote it like this that this is OH, then the CH2 next to O, 3.4. Uh, the multiplet that's CH3. Well, that's even more confusing. I mean, the easiest way was you just tell them, draw the structure and tell them this is this one, etc. ठीक है? वो clear है?
Yes, sir. That's the more easy way.
हाँ.
ठीक है.
ऊपर से you have space for that, ठीक है? So you can, that's the clearest possible way of writing this. So the next thing was, so all of this is the same. He's asking for the splitting. Why is it splitting? So that's a simple answer. कि भी वो, you'll talk about the neighborhood, right? The way he's answering. That doublet, that means one proton on adjacent carbon. I mean, that's it, okay? So you can explain the splitting pattern. I said now the last thing in the question, the last thing in the question is describe that's what we just did. What will happen if you dissolve it in D2O? Which peak will disappear? इसमें से which peak will disappear? If you dissolve it in D2O.
OH peak, like the last
Uh-huh.
one.
So this peak, OH peak, the singlet will disappear. That's it. Clear है ये?
Yes, sir.
तो वो D2O जो है ना, that will, ये आंसर भी देख लो. OH peak or one peak disappears. Uh, explanation भी पूछी थी उसने? Yeah, he's asking for the explanation as well. So you're going to tell them about this, that the OH gets displaced and it becomes OD instead. मतलब OH की जगह it's now OD, right? So the D exchanges the H. So there's no longer any H over there. ठीक है, clear है? अच्छा, उसके बाद अच्छा, remember these questions are confusing because they're like solving a puzzle. So there's no one approach to solving it. You have to consider a lot of things. Uh, but the isomer approach is the best. You draw a lot based on the information. You draw a lot of isomers, and then you try and match what the NMR looks like. I say, yo, yeah, next one. Yeah, let's try and do this one. As a first thing, MM+1 ratio is given. So what we can do is we can figure out the number of carbon atoms, which is क्या होगा 100 over 1.1 into 0.15 M+1 divided by 4.5. ठीक है? What do we get? Remember, he's talking about P. He says P is an alcohol. So how many carbons do we get?
Sir, 3 carbons.
ठीक है, so it's a 3 carbon atom alcohol, right? So that means the other ones are also probably going to be 3 carbon atoms because I don't think he's adding anything. ठीक है, so that's C3H6O. Now he's saying it's getting converted to compound Q in the following reaction sequence. So it's a 3 carbon atom thing that's getting converted to this thing, and then it's getting converted to Q. And what he did was he gave you the spectrum of both P and Q. I said it's a 3 carbon atom alcohol. That pretty much you only have two 3 carbon atom alcohols. It's either going to be a primary alcohol like this, maybe there's a double bond, maybe there's no double bond, or it might be a secondary alcohol. I mean, you can't have any more structures apart from these two. Is that clear? Ignoring that there might be a double bond because he didn't mention anything about the double bond. ठीक है, so ये clear है? I mean, those are the only two possible alcohols, 3 carbon atom possible. Is this clear?
Yes, sir.
तो अब मुझे बताओ कि this is P. How many environments? 4 environments, right? So which one is it? This one or this one? ये पहले वाले में
Open sir, first one.
ठीक है. The first one has, I think, 4 environments. That's one. ठीक है. उसके बाद this CH2 is different. So then the next CH2 is different, and then you have the OH. So that means you got 4 environments in that, right? तो यही होगा. इस नीचे वाले में कितनी environments है? Like the two C,
3.
because the CH3s are exactly the same, right? And और वो जो आपका the this H is going to have a different environment, and then you have the OH. So that's 3 environments. So that means we're dealing with the primary alcohol, which is this. And look at the splitting pattern. This is going to be a क्या होगा ये? Doublet, triplet, क्या होगा? What is this one?
Triplet.
ठीक है, that's a triplet. मतलब 3 लिख देते हैं. This one is going to be what?
Multiplet.
Sir,
Multiplet है.
I
Because
have a question कि अगर हम मिडल वाले को देखते हैं तो हम लेफ्ट एंड राइट दोनों को देखते हैं कि लेफ्ट कार्बन पे कितने
हाँ,
और
you're
राइट
supposed
कार्बन.
to look at both sides.
Okay.
I said this one. What is this one? क्या होगा this one? Remember, ignore the OH. The neighbor is just two H's, right?
Triplet.
And the OH I told you okay, doesn't cause splitting and is always a singlet. Okay, so that's one. So two triplets, one multiplet, one singlet, right? This is exactly what you're getting. You're getting two triplets, one multiplet, and there is one singlet. Okay. And if you still want to confirm, then you can open the data booklet and then you can figure out or match. I told you don't have to do that. Okay. Most of the time you don't have to do that. So finally you found your answer. You figured out what P is. I said then he's given you
सर
uh,
ये सबसे लेफ्ट में जो पीक है why is it different than others?
really?
Yes, इसकी
Need,
width.
need no specific reason.
Oh,
वो नहीं, it's all about resolution. वो वैसे confuse. They're just trying to confuse you. Okay.
सही है सर.
अच्छा, then P was getting converted into Q, right? So what is Q? Q is अच्छा Q. I told you okay, वो जो your data booklet that's helpful. That's very helpful in identifying one thing, and that's a carboxylic acid. Because the carboxylic acid has a very different peak compared to all the others. It's got a very high chemical shift. So that indicates, I mean, our this peak over here indicates that this is a carboxylic acid. So that pretty much makes sense. It's an alcohol that got converted into a carboxylic acid because it's a primary alcohol, right? So it probably got converted into a three carbon atom carboxylic acid. It got oxidized to it. Is that clear? You clear?
Yes, sir.
yes sir.
बस ठीक है और इसका how many environments? There are three environments. One, two, and three. What is the splitting pattern? Singlet. This is going to be a quadruplet because neighbor is three H's. And this one is going to be a triplet because the neighbor has two H's. So triplet, quadruplet, singlet. And you're getting exactly that. Triplet, quadruplet, and a carboxylic acid singlet. So वो जो data booklet है, that's very useful in identifying carboxylic acids. So बस ठीक है, we figured everything out in the question. I mean, you can solve the rest of the question, but we figured out what the answer is. Is that clear?
Yes.
So, ठीक है, we'll do more questions. ठीक है, we'll do them tomorrow. सही है?
Okay sir. अल्लाह हाफिज़.
Okay, take care.
Okay, sir.
Allah Hafiz.
Take care.